In this video, we're going to talk about how to graph multiple transformations for the same function. So in previous videos, we've talked about the types of transformations separately. We've talked about shifting and reflecting and stretching or shrinking a graph. And so now we're going to see some examples where we're doing multiple types of transformations. So the thing to keep in mind is that changes on the inside of the original function affect the x values because they're inside with x. And changes that occur on the outside of the original function are going to affect the y values. Those are your vertical changes. So I would suggest to deal with one direction at a time. It doesn't matter which you deal with first, the x or the y values, but I would highly suggest making a table of a few points on the original function and then use that table to do the transformations. And again, focus on the x column and the y column separately, one at a time. So here, for example, we have a transformation of y equals x cubed. We can tell by the exponent there. And so we're going to start by thinking about what the graph of x cubed looks like. And so you can just pick some x values and substitute them in. For all of our basic functions, I would definitely say you need to use 0 because that's always a really important point. And then for most of the functions, I would say choose a point on either side of 0. Of course, that's not an option with the square root function, though. So we have this type of shape, remember, for our x cubed graph. So let's do the x direction first. It really doesn't matter which direction we focus on first, but we want to think about the x and y direction separately here. So if we look inside of the cubing, inside the original part with x, that's where we see things that affect the x values. And so we can see that x has been replaced with x minus 4. And so that means we're shifting 4 units to the right. Now with the x direction, remember the operations are almost kind of backwards seeming. And so you don't want to subtract 4 from your x values. That will actually move it to the left instead. So you can kind of think about it as doing the opposite operation, I suppose, for the shifting, or you can kind of visually maybe make some tick marks on the axis to help you out. Since it's just a shift. If we have multiple types of transformations in the horizontal direction, we'll address that in a later example here, and we'll show an easy way to deal with multiple at once. But if the only thing that's changing horizontally is shifting, a lot of people will just decide to eyeball that. So for example, if I'm at -1 here in this first point, now I'm moving it 1, 2, 3, 4 units this way. I don't usually draw this on the board in person, but I have no way of pointing at my screen and counting over so you can see my fingers. So that's my illustration. So if we move that point 4 units over, it's at 3. Oh, but we don't know what the y value is yet. Okay, so we'll just put the x value in the table there. All right, and then if we're at 0 and we move 4 units to the right, then we'll be at an x value of 4. And if we're at an x value of 1 and we move 4 units to the right, we'll be at a y value of 5. So that takes care of the x values. Now let's look at the y values. So for the y values, that's being affected by anything that's outside of the cubing. So the 2 here and the 5 here are affecting the y direction. Now, notice between the 2 and the parentheses, there's no symbol. So that's multiplication right there. It's 2 times the stuff inside cubed. So that's your multiplication. That's your stretch factor there. I'm having a hard time writing on the edge of that screen there. Stretch coming from multiplication. And then here's your shift, because notice how there's addition there. So stretching and shrinking comes from multiplication. Shifting comes from adding or subtracting. So the nice thing about the y direction is the operation you see is the operation that happens to your y values. So what you can do is take these original y values, multiply each of them by 2, and then add 5. And multiplying them by 2 will do the stretch, and then adding 5 will do the shift. It's important to do them in that order because we stretch or shrink around the axis, and if we shift first, that's going to mess it up. Also, you can just remember order of operations. We always multiply, then we add or subtract. So, for example, the first y value in our original table is -1. So if we multiply that by 2, we have -2. And then if we add 5, that gives us 3. So that's the y value for the first point. Okay, then the next one is 0. So if we take 0 times 2, we have 0. And then we'll add 5. So we'll have 5 there. And then same for the last y value, which is 1. So 1 times 2 is 2, plus 5 gives us 7. And so now we have the y values of our points. So now we can go ahead and plot these points here. So we have 3, 3, 4, 5, 5, 7. My graph's not really to scale here. Kind of scrunched, but you get the idea. All right, let's look at another example. So here we have a transformation of our absolute value function, which has a V shape with a sharp corner at the origin. And we can then substitute some x values in to get some points to work with there. Okay, so in the x direction, what's happening here is that x has been replaced with x plus 1. So that means we're going to shift to the left 1. That's the only thing inside the absolute value with x, so that's the only number that's affecting the x values. So we can, again, do that visually if you'd like. So, for example, this x value was -1. If we bring that to the left 1 unit, it'll be at -2. The point that was at 0 is going to come over to -1, and the point that was at 1 is going to come over to 0. Okay, that's the only thing changing the x's. Now, everything outside the absolute value affects the y's. So we have a -1/2 times the absolute value, and then we have a subtraction of 3 at the end. So again, you can just do those operations to the y column. Multiply each y value by -1/2, then subtract 3. Make sure you do them in the correct order. So multiplying by -1/2 is going to do a couple things. It's going to do a vertical shrink because 1/2 is less than 1. And because it's a negative, that's going to do a reflection as well. So you can think of -1/2 basically as -1 times 1/2. So that's why we get both a reflection and a shrink. And then the -3, of course, is going to shift it down 3. So it kind of helps to know what to expect so that you know at the end if your graph looks like it should. But again, the easiest way to get the coordinates is just to do the operations to the y column. So if we take 1 times negative 1/2, we get negative 1/2. And then if we subtract 3 from that, we get negative 3.5. And we had 2 points with a y value of 1 in our table for the original. And then we had a y value of 0. So if we multiply that by negative 1/2 and then subtract 3, that will give us the y value for that point. So scale my axis here. All right. So there's the 2 points that have the same y value, and then the one that is the corner of the V is right here at -1, -3. So because of the reflection, the V is upside down now. And so this is what the graph looks like.